In this video, we are going to focus on our trig section of 5.4, which is all about the sum and difference identities of sine and tangent. So these are two new identities that we want to discuss. So let's get right to it. So our first one is sine. And so for our sum and difference of sine, hold on. So sine, if you are adding your two values together, okay, you are going to take the sine of your first value, and then you're going to take the cosine of your second value, keep the symbol the same, and then cosine of A, and then sine of B. And its subtraction is exactly the same, except there's a subtraction sign in between. Okay, so things to kind of point out, right? Sine and cosine now are together versus when we were dealing with just the cosine of the sum and difference. But notice that still your A value is still first, okay? So you do want to have your A value first, and notice that your B value is second, okay? There is a tune that you can memorize this to, and it is head, shoulders, knees, and toes, right? So that little song, right? So head, shoulders, knees, and toes, knees and toes. So how we say it is we're going to say sine, cosine, cosine, sine, keep the sign, right? So sine, cosine, cosine, sine, keep the sign. So again, it's a little song to kind of help you remember your tangent or your sine. For your tangent, now tangent's a little bit different. There actually is no song that goes with it, but tangent, you actually only use tangent, so that's nice. So this will be the tan of A, because that's our first value, plus the tan of B, so far looks good. And then we're going to divide that by 1 minus tan A, tan B. So you have to use both of the values twice. And one is you will either add or subtract them, the other ones you will multiply. So when there's a subtraction sign in between, you will subtract the two tangents together, and then on the denominator, you'll add it with whatever you multiply, tan of A and tan of B, right? So there are opposite signs on the top and on the bottom. Okay, and these are our last two sum and difference identities. So we don't necessarily need one for secant, cosecant, and cotangent, because again, we could just flip those numbers and we would get our reciprocal that way. So how can I use these identities? All right, so let's take a look at some examples. So let's find the exact values. So here's our first one. I'm going to say the sine of 11 pi over 12. Now, in the last video on 5.3, we kind of looked at changing any of our radians to the denominator of 12. The other way that we could look at this problem is I can think of some numbers that add to 11 pi over 12, right? So I could do pi over 12 plus 10 pi over 12. I could do 2 pi over 12 plus 9 pi over 12. I could do 3 pi over 12 plus 8 pi over 12. I could do 4 pi over 12 plus 7 pi over 12. 5 pi over 12 plus 6 pi over 12. Now, some of these numbers are going to be good, and some of these numbers are not going to be good. So for instance, I would not want to use this one. I would not want to use pi over 12 because I cannot simplify pi over 12. That's not on our unit circle. I also would not want to use this set of numbers because again, I can simplify 4 pi over 12, but I can't simplify 7 pi over 12, so that would not be a good fit for me. 5 and 6 I also don't want to use because 5 is a prime number that cannot be simplified into 12, right? So, so again, that would not be a good set of numbers. But everything else is pretty much fair game, right? So let's go ahead and just let's take 3 pi over 12 plus 8 pi over 12. So this would give us the sine, and again, 3 pi over 12 plus 8 pi over 12. So I can simplify this. This would be the same thing as just pi over 4. And the number that goes into both 8 and 12 should be 4. So this would be, what, 2 pi over 3. So again, these two values are on our unit circle. The very first thing I always want to do is I want to break this up. So again, this is your A and this is your B. So it becomes sine of your A, cosine of your B. Oops, not 2. All right, so 2 pi over 3. Keep the sign the same, so plus. And now I switch my cosine and sine, but keep my number. So pi over 4 and sine of 2 pi over 3. Again, I can simplify these numbers, and pi over 4, that'll just be root 2 over 2. My cosine of 2 pi over 3, that is in my second quadrant, so I'm going to put that in parentheses, so the negative 1/2. Pi over 4, again, that's a root 2 over 2. Sine of pi over 3, that is your root 3 over 2. Now, I didn't need that one in parentheses. But when we go ahead and we multiply, I will be given negative root 2 over 4 and a plus root 6 all over 4. Notice, again, very similar to when I found cosine of, if I found cosine of this number, I still get 4 as the denominator, and I still start seeing root 2 and root 6. So this value is 11 pi over 12 is going to be negative root 2 plus root 6 all over 4. Now, depending on, erase that. Depending on how you originally wrote this, right, your negative 2 might be second, so we might see root 6 minus root 2. Again, the order doesn't matter as long as the values stay the same. All right, what happens if the problem looks something like this? Sine of 100 degrees, cosine of 10, minus cosine of 100 degrees, sine of 10. So what do we notice about this problem, right? Well, the first thing you should notice is that 100 and 10 are not on our unit circle, okay? So that's the first thing that I notice. But I know sine and cosine are together, and again, sine and cosine are together on the second side. And I notice that the first value is 100 on both the terms. And I notice that the second value happens to be 10. So again, this is kind of looking like your identity. So when you don't know, go backwards. So again, this is your A, this is your B. Again, this is your A, this is your B. So we're going to go backwards using our identity, right? And we are going to write it like that. So I'm going to say that this is the sine of 100, and then keep the sign the same, so minus, and then 10 degrees. Let's see if we can simplify it some more. This becomes sine of 90 degrees, and 90 is on our unit circle. We would never use the sum and difference to find 90 degrees because we would just have it memorized. And so it gives us the number 1. All right, so we've seen some with sines. Let's check one out that has to do with tangent. All right, so this will be our third example. So what happens if we find out that we need to figure out what is tangent of 285? Okay, in general, anytime you want to find tangent of a number, we want to rationalize. So rationalize denominator. And we'll talk about that in this one. Now, here's our next problem. 285 is not on our unit circle. So again, we have to think of some numbers that are going to multiply, sorry, not multiply, are going to add or subtract to give us 285. Okay. So the first two numbers that come to my mind is going to be 240 plus 45. Okay, so tangent of 240 plus 45. So I'm going to use my identity. So this will become tangent of 240 plus the tangent of 45 divide by 1 minus the tangent of 240 times the tangent of 45. Now, tangent is one of those numbers that we don't necessarily need to memorize, but we can derive it. All right. Now, 45 is the easier one. 45 is in our first quadrant. And so remember, tangent can be made up of either we can think of it as y over x, or we can think of it as sine over cosine. Either one. So I know 45 is at the point root 2 over 2 and root 2 over 2. So if I was going to take my y value, root 2 over 2, divide it by my x value, root 2 over 2, we will notice that we will get exactly the same thing. So everything will cancel out, and this will leave you with the number 1. Right? So when I think back to my problem, I know that this will be plus 1, and over here it'll be 1 minus, we don't know what this is yet, so I'll just say times 1. All right, so how do I find 240? Well, 240 is in the third quadrant, so 240, okay? And for 240, okay, how I want to derive that, I'm going to take my x value, negative 1/2, and my y value, negative 3/2, and again, I'm going to divide those together. So when I do that, I am going to, and I'm just going to flip it right away, and flip it to, instead of dividing by negative 1/2, I'll multiply it by a negative 2 over negative 1, or sorry, positive 2 over negative 1. My 2's are going to cancel out, and so are my negatives, so I will be left with a negative root 3. So that value, or sorry, not negative, my fault, the 2 negatives cancel out, it should be positive. So positive root 3. All right, so looking at this problem, I don't necessarily need root 3 times 1, so I can just leave this as just 1 minus root 3. This problem right here is not rationalized, okay? So I said we want to rationalize our denominator. So how do we go about and do that, okay? So looking at our problem, what we are going to do first is we are going to multiply by the conjugate. So the conjugate in the denominator should be a 1 plus root 3. And if I multiply 1 plus root 3 on the bottom, in order to make sure that my problem stays exactly the same, I need to multiply it on the top. Okay. So for here, come over here, I will multiply my numerator. So this will just give me a root 3 plus a root 9 plus 1 plus a root 3. In my denominator, 1 plus root 3 minus root 3 minus root 9. Simplify this out. All right, this will give me a root 3 and a root 3, so I get a 2 root 3 plus 3 plus 1. On my denominator, I get a 1 minus 3. Again, I can simplify this a little bit more. So I'll bring it up here. 2 root 3 plus 4 all over negative 2. So again, I got rid of my radical in the denominator. I can simplify this even more. So we can break up our fractions. And so I'll be left with a negative root 3 minus 2. This is the answer that I'm looking for. This means that it is rationalized. Okay, and as you kind of go through this, you'll notice that when you find your tangents, you're going to get similar answers each time. Okay. All right, what other type of problem could we see? Well, we could see this type of problem. So I'm going to say we're going to find the, oops, let take away the word the. We're going to find the sine of a plus b, and we will find tangent of a minus b. So we're not necessarily finding a and b. So for these problems, we don't need to rationalize ever. So don't rationalize. Okay. So let's give some more information. So I'm going to tell you that sine of a is going to equal negative 5 over 13. Sine of B is going to be 3 over 5. A is going to be in quadrant 2, and B is, oh, sorry, not quadrant 2. Let's make that quadrant 3 since sine is negative. So let's make that quadrant 3. And then let's make B quadrant 2. So we'll switch those up. Okay, so the first thing I'm going to do is I'm going to start with what I know. Well, I know that sine of A plus B is sine of A cosine of B plus cosine of A sine of B. All right, so I know sine of A, so that's negative 5 over 13. I don't know cosine of B, so I'll leave that blank for just a moment. Cosine of A, I don't know yet, but sine of B I know, and that's 3/5. Okay, so now I got to do a little bit of work. Okay, so off to the side, I'm going to figure out my A value. So again, I'm going to use my lovely Pythagorean theorem. So x squared plus y squared is equal to r squared. Now this is a perfect Pythagorean triple, but if we forget that, that's fine. We can always solve it the long way, right? So 25 plus x squared is equal to 169. X squared is 144. Again, I get plus or minus 12. We're paying attention to it's in quadrant number 3. So that means that it should be negative. So this will be a negative 12. And this time it will be all over 13. All right. Want to do the same thing for B. So again, if you recognize that 3 and 5 are part of Pythagorean triple, great. If not, let's do it the long way. So 9 is equal to 25 plus x squared. So x squared is equal to 16. Again, plus or minus 4. We pay attention, it's in quadrant 2, so x should be negative in quadrant 2. So this will be a negative 4 over 5. Okay, once I got that, notice I don't have any radicals. That's nice. So I can just go ahead and I can multiply it all together. So this is going to leave me with 20 over 65. And then positive, negative, positive. So this will be a minus 36 over 65. Now I can continue this problem a little bit more, right? And this will actually give me, I'll actually put it down here, sine of A plus B. And so this is going to give me a negative 16 over 65. And that's my answer, okay? Now, how do I find tangent? I'm going to, let's see if I can put this all onto right here. I'm going to change my color up so we can see the difference. Okay, so for tangent, it's going to be tan of A minus tan of B all over 1 plus tan of A tan of B. Okay, problem, we don't know tangent, but I have found all my work already here. So I'm going to say that tangent of A, and we're in the third quadrant, tangent of A should be positive. So it is going to become a positive 5 over 12. And I will add that to my tangent of B. So that'll be a positive 3 over a negative 4. And again, where the negative is, doesn't quite matter. And then 1 minus, oh, sorry, I switched this around. This should be minus over here, so minus. So this will be plus. And then this will be a 5 over 12, and I'm just going to make that fraction negative 3/4. All right, so let's follow it here. The two negatives are going to cancel each other out, and while I'm at it, I'm going to make them be the same denominator. So I'd multiply, change my color, 3 and 3 on the top and on the bottom, and so this will become 9 over 12. On the denominator, I can actually simplify. My 3 goes into 12 4 times. So this will become 1 minus 5 over 16. Now, 1 can be changed to a 16 over 16, right? So it'll help me multiply things together, right? So 5 plus 9, that gives me 14 over 12. And then all of this will be 16 minus 5, so this will give me 11 over 16. Now, I don't like writing fractions like this, so what I like to do is I like to write it as a divide sign. So 11 over 16. So this will leave me with 14 over 12 times 16 over 11. Now, 12, the number that goes into both 12 and 16 is 4. So that means that this will become a 3, and this will become a 4. So if we multiply my 4 by 14, I should get 56, and 3 times 11 gives me 33. Now, again, we didn't have any radicals, so we actually did not need to rationalize our denominator. But once we've collected all of our fractions and you got to you got to this point and it still had radicals in it, we can leave the radicals alone. Okay, and that is your sum and difference of sine and tangent identities.